For me, conservation tech is the way of the future because one of the ways we'll be able to solve all of these problems is by making our processes more efficient and gathering more sensor data, like sensors beyond what we just have. It's essentially like trying to create a helper for nature. And so that's what it means to me. I like that, and I want nature to keep on going.
Great. Toby?
Yeah. So for me, um, my interest around that field is just like uh, our world is so much not corrupted in such a way, but it needs some solutions that has to be from the grassroots level, like in our oceans, in the forest, in the way we eat, the way we do things. So bringing these kind of conservation projects, it's kind of interesting to pursue these problems and solve them. So these are kind of so in-depth to me in my heart, and trying to solve this and make people think that this solution would help them, live more in this world and have more prediction about if rain is going to fall tomorrow or not. So
Yeah, so one of the things that we've talked about on this kind of podcast or talk show before is the thought of a lot of conservation technology being like opportunistic. So a lot of it is, and this is a term Shaw uses, which is like opportunistic tech is things that are built for something like the military and then applied in a completely different way to like, so camera traps is a big example of this in this space. So I'm curious a little bit of could y'all kind of comment on what your thoughts are on kind of where conservation technology is right now and some of what y'all are doing to kind of, Aaron, I know you said you've built some robots before. So what do you think is changing about the landscape now? And could you talk some about that?
Sure. Uh, so, I mean, I don't have a lot of um, experience to say how it has changed over decades, but I can say how it's changed while I've seen it. And one of the ways I've seen it change is with more citizen science technology becoming available, like as products that you can purchase yourself. So, for example, there is this initiative I believe called Water Ranger, and over the course of maybe 3 years, they were able to launch this portable water testing kit that anyone could purchase, or they lend it out, sort of like a library. And that way, people can take the water readings and then log it into their app. And then we're getting this sort of crowdsourced data from citizen scientists. I really like that part because it involves people and we can do more efforts together, especially when it's involving better sensors or more intelligence. Where I haven't seen it changed a lot and it's sort of frustrating is going beyond sensing and into the actuation realm. So, for example, with my robot, it was both sensing and then both also actuating. So it would sense the garbage and then also pick it up. And it seems like where a lot of these tech projects are stuck at is like they don't act on the data that they're collecting. It's just like, here's another sensor node, and that one will be successful and get some seed funding because it has a business model that's relevant for the current market. However, because the market doesn't exactly need things that actuate in the world right now, then that dictates that the like really out there projects don't get as much resources. So I would like to see it move in the realm of more actuation, more robotics, essentially.
Toby, do you have any comments?
Yeah, in addition to what Erin said, my own perspective about the intelligence part is it's so seamless. Adding more intelligent system to different conservation projects, because we have AI now, we have Internet of Things, we have all these intelligent systems. Bringing it to this kind of solution will make the life more easier. We make it more innovative, and this is the area that I feel like it's more important. Imagine you don't have to physically there and control some of your devices so remotely, maybe from Nigeria, and you have your devices in Canada, or someone in Canada would be able to control it, and you can have a broadband, a broader devices all connected, talking to each other, and this is kind of very interesting to see it happening in our lifetime. So yeah.
So what are some of the things that make you most excited about this space right now? Like about conservation technology? Like what are some projects, some things that y'all have worked on, some things that you are seeing that make you really excited about the future of this? Because I know you talked some about I think, in actuation, Aaron. But are there some things that are happening right now, some technologies that are making you really excited?
There's been some creative mixtures of technologies lately, like, for example, equipping a drone with an airsoft gun, and instead of pellets, it shoots out seeds, and those seeds are like composed of like special seed pod stuff, and that's used to plant trees in areas that would be difficult to reach by foot. That's pretty cool. Um,
Yeah, I hadn't heard of that. That's really awesome. So basically a seed dispersal. Seed dispersal. It's kind of like almost. I mean, it's almost like a keystone species drone, something along those lines. That's really really cool. Toby.
Well, while making some survey, I begin to realize that this is a very, very big problem. And if it's been solved, a lot of life will be changed for life. Like it's just going to go in another dimension for them. This is also very cool for me in this part of innovation. So especially trying to make the survey in the extreme local areas in Nigeria, and having a chat with them. And what they keep telling me is that they never expected that technology could go into this level of solving this kind of problem, because they've been fishing for over 100 years, and this is the way, this is the method, they, they, the way they do it all the time. So why now bringing innovation to it is just extremely useful for them. So yeah.
Yeah, and I just realized, could y'all actually kind of talk a little bit more in detail on what exactly you all are doing in this space? I know we did a little bit of that in intro, but could you talk about like what is it that you all are doing? Because I know I've gotten to see some of the YouTube video talking about fishing and some of those things, Toby. So could you talk more in detail about what some of y'all are doing in terms of being on the Dream Team?
Oh yeah. So if it's about, you mean the individual contribution or the whole
Yeah,
project
so
as
why don't we do a little bit of both? So if you want to talk about the entirety of the thing, and then talk about a little bit of your individual contributions, and maybe somebody can clue in a little bit of what Leonardo is doing, because I think he's still having some
yeah.
difficulties.
Okay, yeah. So it's about ghost year. It get lost in the ocean. This is, if I sleep and wake up, it's always ringing in my head. That's ghost year, ghost year. So, and we didn't realize that until we even go in depth in-depth research, and we see that this is a worldwide problem that people are trying to solve. Ghost share get lost in the ocean. What about if we bring in some intelligent buoy system that can be tracked, that can be configured to be released at a particular time, that can be configured to be, withdraw at a particular time, or just configure everything with your intelligent system. So this is the direction we are going to solve. And in my case, with Leo, we are the one in charge of the electronics parts, which is firmware and the PCB. Leo is the one designing the PCB board. I'm the one writing the firmware. And yeah, it's been really interesting. We just try to, we're all remotely situated. So we're trying to use different components that would make us still work remotely so easy without any trouble. So I think Erin can also talk more about what she's doing and about the projects. Yeah.
Yeah, that was a pretty good summary. So the Hackaday Dream Team is in partnership with Conservation X Labs, and every single year Hackaday runs this competition called the Hackaday Prize. This year was so different because of the pandemic, and also they're partnering with a nonprofit partner. So we were all selected to work together on this ropeless gear challenge. When we started looking into the problem a bit more, it became evident that there's a few different slices of the problem. There's like retrieving ghost gear, there's preventing ghost gear, there's reducing vertical lines, and then there's like things beyond that. Like, what if we could know how much fish are entering the nets, or know how many lobsters enter the traps? So we've been working hard on a ropeless system, and the ropeless system involves a spool box that would reel in the rope, or reel out the rope, an intelligent buoy that sits on top of the spool box, and then inside of the intelligent buoy there could also be a monitor. That monitor could hopefully detect fish around. There's also going to be a gateway to join the LoRa network to cellular, so that everyone can see the data if there's service there.
Oh, so you're going to be making everything open source?
Yep, everything's open source, which is great because there's a few startups in the ropeless gear area. So we know that, like, first of all, our tech will hopefully be able to benefit fishers, and also hopefully be able to benefit the community in that area too.
That's all. Yeah, I'm actually afraid of the ocean. I don't know, maybe too many shark movies or something like that. But I think it's one of the most interesting parts of this space because everything gets more complicated. I feel like when you're on, especially in an open water, because when you think of any sort of electrical equipment, you have the additional difficulty of being surrounded by water. It's like I just think of Pokemon. It's like it's super effective against any sort of technology. But yeah, I'm curious. What are some of the biggest challenges that y'all have faced in this? And I also would just like to point out it's awesome. We've had some conversations on here about making things open source and how important that is. So it's really awesome that that's something that is kind of at the forefront of your project. So what are some of the biggest challenges that you faced?
Oh, wow. Biggest challenges on my side for mechanical and design has been fitting things into a small enclosure, and then conversely, soon it will be designing an double O-ring seal for a different type of enclosure, and just the various amounts of design that's happening right now is challenging. The
How small?
logistics between shipping for 3 different countries is also tricky.
Yeah.
How small is the box setup that you have?
So for our enclosure for the intelligent buoy, we're actually using a water bottle, a Nalgene water bottle. So this is great because it's polycarbonate, so we know it's durable. Um, so the problem is that this entrance is very tiny. So the design lab that's a part of Hackaday or Supply Frame, the main company, they're going to chop off the top of this. And so that's where we'll have like 2 different types, an A type and a B type. And yeah, so then the spool box is just a little bit larger than this. And then it's sort of like, I don't know, maybe going to be that big or something. That part is still in the works.
Awesome. Toby, what about on your end?
Challenges. I think it's about, far away distance, and you have to order for components, and you have to wait for some time to do some testing. And some of the components are not even locally available. So I think that's but it's still very fun because while waiting for the components, you still have to keep writing your firmware, design the PCB, and we even got some PCB manufacturer locally in Nigeria that would as well help us with the PCB design. So, but then the only challenge is just the shipping, that you have to ship from different suppliers, and everything just goes to the US, which is the design lab, and the design lab will pack everything and distribute to 3 different continents, Venezuela, Nigeria, and Canada, So that will take a lot of time. This is the only challenge I think we're all facing, but it's cool because it's COVID, so we're not supposed to travel, by the way, so we can all work in our house and just build something.
So I'm curious. Have y'all ever actually met in person? Like, is that the reason I ask is so I'm a PhD student at Georgia Tech, and I teach a class on conservation technology. And what's funny is I hired a undergraduate student to do research, and we've never met. And this fall, again, things are going online, and like we might go to a virtual conference together, but it's just kind of funny to me because I feel like we're in this stage of great collaboration where a lot of just people have still just never met in person, and obviously y'all are all pretty far away from each other. So is there opportunity? Sorry, Toby, go ahead.
Yeah, so, I mean, it's just cool because when Hackaday was able to, I've never seen robots get before. I'm talking about hearing. I'm just surprised that in this space, I've not seen, because she has been doing a lot of work in the field of robots and all these things. But it was so surprising that I've never seen her work until Hackaday brought us all together, and it's now look as if when we're done with this project, we got to grab a coffee when COVID is out and meet in person, somewhere in between. It could be in the US, or all of us will just travel to Canada and see physically. But it's fun that we've been bonding, that we always talk almost every day. This time supposed to be our daily call. So, and sometimes we even talk from Monday to Sunday, and on Sunday we just together that, okay, I think I'm done for the week. I don't want to see your face again.
Yeah.
So,
I feel like we get some of I do a lot of my meetings on Zoom, and you get kind of Zoom meeting burnout a little bit, and I think we're experiencing some of that, especially with classes starting some this fall. So, what has been some of the difficult parts about? I mean, obviously, there's you're spanning three different countries. What has been some of the difficult parts about implementation between like in doing some of these projects? So, so it sounds like Aaron, are you doing a lot of the building and then you're sending it, or what is kind of the timeline process of some of the how some of this stuff gets implemented?
Yeah, that's a great question. So the timeline for implementation is actually the deadline to receive from the 3D printed or 3D design files is this afternoon. So that's why I've been yawning. Sorry about that. I kind of stayed up late and early. So uh, once the design lab has the 3 files, they'll be printing the pieces, and then those pieces are going to go into boxes for shipping to Toby and shipping to Leo. And also in those boxes will be some like DigiKey parts, some other miscellaneous electronics, as well as Nalgene for the enclosure. So the integration is, we decide at the start that we're all going to build the same thing wherever we are.
Bless you.
And so that produced some interesting things. Luckily, we can all solder, and we're all pretty well versed in like electronics and microcontrollers and that sort of thing. If it wasn't pandemic time, I think the 3D printing aspect would be easier. However, like uh, it's it's just that risk, you know. Do you want to go into a fab lab and try to print things if they're even open, or they could just be shipped in the box that's also being shipped? So it's not like it's a detriment there because it's already being shipped. So once we all have all the same pieces, then it's going to be like the most fun because we'll all be prototyping and coding and hacking on the same things and trying to make it work and then testing it. So yeah, that's how the integration is going to go. We're like right at the deadline today.
Oh my gosh. Well, good luck with that deadline. I didn't know I was catching you on deadline day, so I can only imagine. So one of the things that a lot of engineers, builders do, in my opinion, with conservation tech is they never have like the end user of the technology in mind. So I'm curious, what are some of the ways that y'all are thinking about the end user in development of this technology?
Could
Does that question?
answer
Yeah, does
that,
that make
and
sense?
then we can go to Toby too. So yeah, it makes perfect sense, and also it's kind of important for almost any sort of project that you're working on. Who's going to use it and making sure you get their feedback on it. So with fishers, it's particularly difficult, and that's just by the profession of fishers. And Toby can go into more of that. What we've been doing is like trying to reach out to anyone who knows any fisher, essentially. Had some luck with someone from NOAA, so that was good. And also Toby and Leo also had some luck finding a fisher. So it's still tricky though because these um, contacts take time to like build up rapport. Uh, sorry. So
Yeah.
that
Rapport. Yeah, I there's some words that I despise as well. So yeah.
because like they have to really sort of begin to trust you and sort of trust that the tech is worth their time to test, and the fisher's time is so valuable because everything they do is extremely rapid. So it's going to be tricky to find the right testing environment and the right beta tester for this. But that doesn't mean that we're not trying. And actually, we think this is a really important thing. So, yeah, Toby, more thoughts on the fishers?
Yeah, Aaron, thanks. Um, I think it's just it's the same as you said, like try to make some research in different continents and bring it together to understand the pinpoints. And we now narrow down the pinpoints that what we're solving, will it be helpful to all the fishermen in all the continents to some extent? So, and that's one of our pinpoints of the research. And for me, I went in depth to some fishermen in Nigeria, which is the Lagos, one of the most busiest city in Africa, with family of fishermen that they've been fishing for only God knows, maybe 100 years. And this is a routine for them, and it's a um, family business or family way. It sometimes work like that in Nigeria, that if your father is a pastor, all of you must be a pastor. And for these fishermen, their grandfather, great grandfather is a fisherman. So all the children are into fishing. So one of the questions we even ask them is, how do you do your days? How do you go out for fishing? Do you have a book? Do you make a schedule? Do you read something? But it's not the same in fishermen in Nigeria. They just wake up and go out at 5 a.m. and fish. No timeline, no deliverables, nothing. They just go out. So, which is kind of different for some other professional fishermen. And we also like go in depth. There is a company that they have partner in Canada that they are also into this fishing, conservation, and all these kind of projects. And we had a chat with them, and we asked them, "What do you think about this ghost jet problem?" They said, if I go to their website, they've listed that this is one of the most critical problems for them that they don't know how to solve, and they want to even be our first tester when we are done with this project. But I mean, COVID might not allow us to go around and still test, but we can still arrange with them and do different tests in different continents. So it's a different story from different people, but it was really a great privilege to meet one of the core fishermen in Nigeria that they are extremely focused on a very low end fishing, that it's not using ship, it's just their canoe. I don't know if you know canoe, this a wooden part of going out inside the ocean and just fish. So yeah, those are the kind of research that we gather, and it's really, really valuable for the research that we worked on.
So I'm curious, right? Is there differences with I'm not sure on which side of Canada, but is there differences in Atlantic to Pacific Ocean? And is there also differences when you're thinking of things like, I'm just thinking of the United States, of like the Gulf of Mexico, right? And because I feel like some of these different um, oceans, bodies of water, and stuff like that might also bring up different challenges. And so the where this question kind of comes from is this thought of universally deployable technology, right? So applying this anywhere in the entire world. So could you talk about maybe if there's some differences in those? If and I'm just curious with I know he's not here, but also looking at South America, if there's some differences there as well.
Yeah, there's certainly differences. Lobster trap fishing is more common on the eastern side compared to the western side. Something else that's interesting, backing up a bit to think of a high level problem, we also want to avoid entanglement with right whales, the North Atlantic right whales. And what's fascinating is that those whales have a counterpart on the other side of the continent, and it's only the eastern side that has seemed to be really endangered. But going back to your question, there's all sorts of different scales of fisheries. There's different gear types. And of course, there's different environments and locations too. So it does make it a really good opportunity for something that's universal to be put in place as a piece of technology. That's one of the reasons why we decide that when we're building these systems, it would have the intelligent buoy that could also serve as other types of either sensor nodes or attach onto the gear somehow. But yeah, universality is pretty key since everything is such a variety.
Toby, any comments?
Right. So Erin already said everything about the universal. It's just it's just the same as she said. And about regulation, I think we also touch with about regulation in different continents and see if there will be regulation that would disrupt us from developing this innovation. So, for example, in Nigeria, there's no specific regulation around this. Yet, maybe when they see it's implemented, they could start raising some flag and say you have to file this regulation or something. But right now, there's no a specific method. But of course, no one can go inside the ocean and just start fishing in Nigeria. You have to. So this is tricky. In Canada, I think when we were having the discussion, it's more of a professional level of fishing. But in Nigeria, it's more of a community level of fishing. So if you want to go to the ocean, there's a king, or we can call them city, no, it's a community leader, something like that. So you have to talk to the community leader that you want to start fishing. And they would say, oh, do you know how to fish? What is they could ask you some very simple question, but it's not technical. It doesn't, because they didn't go to school, so it doesn't have to be technical. But it's the same. I mean, it's different from the one in Canada that it's all professional. So if the community leader in Nigeria say, hey, you can start fishing, congratulations, you just won yourself a fishing platform in the community. But you can't just go inside the ocean and start fishing without community acceptance or community guidance and say, hey, you can go ahead and start fishing. So that's another kind of things that we find that during this work.
So when we were talking some about like the end user and that, so Toby, what did you communicate with this like community? I think you called them king, but like this community leader of fishing. Is that one of the people that you really needed buy-in from in order to actually successfully implement this project?
Not necessary, because I didn't talk to the community leader, but those are the kind of information I gathered from the fishermen. I'm talking about there's a family I met that this is what they do for like over 100 years, like their family. They've been doing that same thing, and it was passed across to them. And I was able to gather a raw information of the process from them. So, but maybe if this goes out open source wise, that some people can start building, maybe it's something that we can talk to community leader and introduce it to them, and they can make it regulation that before you start your fishing, you should use this device, you should use this technology. So we can influence policy if we're able to successfully penetrate, especially in Nigeria, that there's no standard policy yet. So I think that's the way I see it.
Awesome. Yeah, one of the things, I guess, again, Tom, who's also been on the podcast before, knows a lot more about the ocean than I do. I'm more of a land person. So, but one of the things with climate change, I know that's impacting a lot is salt content in oceans. And so, is that something that is any sort of limiting factor with your design in looking at different salt contents, and if the salt content keeps increasing, is that going to mess with any part of the buoy? I was curious if that's something that you have looked into.
That's a good question. So, the polycarbonate is a pretty durable material, so we don't expect much corrosion or biofouling on the buoy. For the spool box, we're aiming to use HDPE, which is also really good material for use in those types of harsh environments. Yeah.
Yeah, no, I mean that all makes sense.
However, we will need a ballast for the uh, spool box. So that might be steel, and that may have um, some corrosion. But yeah, so those are the reasons why we chose those materials. No biofouling on HTP, which is nice.
Yeah, it's kind of this to me. It's I mean, when you think of climate change on a global scale, it's interesting because I do a lot of just um, like conservation work for mammal species, and if you look on any mammal species, why are they endangered? One of the reasons is climate change, right? And so it's kind of this overarching or overarching question or issue or problem that we have to kind of constantly think about in terms of this. So yeah, so as we kind of we've been going on for a while, and I know only want to take an hour of your time, so we have about 10 minutes to wrap up here. But one of the things that I wanted to ask about is, so what are some of y'all's like future aspirations? What are you hoping to do when this kind of completes? I know, Aaron, you talked about that in the past you've done a lot with some technologies, and I'm curious what is kind of the plan for the future of when this project is completed. Are you going to continue on this sort of conservation technology venture? Or are you going to move towards something else? So, Toby, would you like to start? I
I was
picked
thinking
on I've picked on Erin enough for her to start first. I think it's your turn.
because I have like a different feelings, and I've been saying that to Erin even yesterday. We discussed about it. It's kind of interesting what we're trying to solve, and it will be more encouraging when we keep innovating in this EJA, because that's the name of our team. We call it EJA. EJA is just a name that is derived from a Yoruba translation for fish. So the plan is just probably we still want, because there's still a lot of things that we want to implement that it's not part of our the timeline, which is more like the computer vision, adding some more intelligence like autonomous and the likes. So these are the kind of things that we would love to still continuously develop on, and then make it open source and make it a non-profit sort of, or that we can still spend maybe once in a week building it, and if we need help, like if we need help to buy things, we can tell people, hey, we've got t-shirts for Hedja, pay $1 for us, and we'll send a t-shirt to you or something, just to continuously innovate around the field of the project specifically. So, because if this turns out like, I mean, we know it's going to turn out fine as per the prototype, but then how about if there's a platform that we can all ship it to different country or different continents, and we just sent it there to do our own more tests as per prototype testing, uh, and we can get feedback from all these continents, and with that we can see that this solution can actually work in all the other countries. So
Universally, yeah, that's really cool. Yeah, so kind of almost get a. Uh, I'm trying to think of right like what the phrase would be, but it almost get like a focus group from around the world, a focus group of fishermen from around the world to implement this and look at every single. I am one thing. I guess I am curious about in general is that this is. Sorry, I'll let you go, Aaron. My brain just kind of goes off sometimes. So go ahead, Aaron, and then I'll ask my next
It's all
question.
good. For me personally, I'm interested in reaching the point where we do beta test this with a fisher, whether that happens by the end of this period of time or beyond that. It doesn't matter. I just want to at least hear the feedback of it being used in reality. But then also after this, I'm interested in trying to think about space sustainability and sustainable power systems for lunar colonization. So I've been working on, like, on the side, not during this project time, but working on a power station for the moon that would wirelessly transmit power to little rovers so that way they could survive the lunar night, and that way we could use less launches, which uses less rocket fuel.
Wow.
You
Um,
can imagine, Erin, that's so big,
Yeah, it's a pretty big goal, so that's kind of the problem. It's kind of
that is the most casual, like, we're gonna go to the moon drop I think I've ever heard. Anyone like, yeah, I'm just building, a few robots go to the moon. So moving on, it's like, wow, that's amazing. So,
I mean, for me, if I'm not gonna like before we started this project, I've been developing a specific solution for the Rwandan country that makes people pay as they cook. In Rwanda, hopefully it could go around the Africa, but this is another way that people should not cook with charcoal or firewood. Charcoal in the US or any other part of the world is like what you use for barbecue. But you can imagine this is actually what some people in this part of the world, in Africa, in South America, and in India, they use that to cook like their real complete meal, morning, afternoon, and night. So one of the things I've been doing in the space is making people, yeah, it's not 100% clean, but then using LPG, which is the gas, for them to pay as they cook, because they cannot afford to buy the cylinder, they cannot afford to replace or refill the cylinder. But one of the technology I've been building with the IoT is that the device will be on top of the cylinder and we give them for free, but they only pay for the gas they use, just like a normal electricity meter that they give you the meter for free, but you continuously pay for your electricity. And it's the same for the semi-urban area, the middle class, the extremely low income earners, to be able to pay as they cook every day, and using this normal technology. And I'm sure you know about the mobile money in the Eastern Africa, that this is what they use generally to buy things. They don't use MasterCard. You can use that to withdraw money or whatever. So you can use that same technology to buy LPG gas. And you don't, I mean, in the UK, there is pipeline running. I'm not pitching my project to you. I'm just trying to tell you the
no,
excitement.
but this is so, Toby. I mean, what this is, right, is what I think you make a really excellent point on. Is this is a little bit of, I guess, what I was getting at with some of the end user is, a lot of people are like, well, just run a pipe, just run a pipe. And what Toby, why are you doing this just run a pipe, like, just run it underneath the ground and connect everybody up to a centralized grid for gas, and then problem solved. And then you just charge people and it's like, okay, well, some of that sort of things, I mean, but that's a amazing, I think that's a really amazing project, and that's a really cool innovation too. And so you said you're starting it in one country and then hoping to expand it to all of Africa.
Yeah, I've started since 2018 in Rwanda,
Rwanda.
and they actually accepted it. So they were part of the government funding project. So in order to research it and see it solved in Rwanda. So the pipeline might not work in Africa because the bureaucracy, you have to get license from the government. Pipeline supposed to be from the government, not from a private. It could be like a PPP, like private partnership, but realistically, I think the one with the device on it. And for us, we're not the one in charge of the gas. There's a separate supply chain that is handling that. So it's just the IoT device itself that do all the tracking, monitoring, payment and all sort of things. So anyone without, you can pay as low as 25 cents and you can access the gas. And maybe after 4 years, you can own the gas yourself, I mean, the cylinder. So it's just a whole lot of research work and yeah. But this
So
is things I'm completely interested to continuously build and see it work in all the African regions. I mean, starting with Rwanda, which is 12 million people, then move to Nigeria, which is over 300 million people.
yeah,
So you
because
can,
I assume with a lot of this, like in implementation, right? Rwanda is geographically, right, is small in terms of um, square miles, right, or square kilometers. The U.S. does everything just really stupid units. But anyway, but yeah, so the hope I assume is, so when you implement in Rwanda, was it community based and then sort of expanding to nation, and then you then go from a smaller geographical footprint to a larger, and then you can slowly kind of then matriculate throughout Africa.
yeah, that's the plan. We've been testing for almost 1.5 years. I mean, we have three customers that they are cooking every day. They're paying. I mean, it's working.